So in this video, I will be sharing how do you answer for achieve merit and excellent question. So we are going through level 3 chemistry, organic compounds. So let's look at question 1. By getting 3 correct answer out of this 4, you'll be getting achieve. So to start working on the structure formula, like any other organic compound, we need to look at the root. So the root is found in the middle as prop, which represent 3 carbon. So I'm going to start by drawing 3 carbon, and amide, okay, would be C double bond O and NH2. Then you have 3 chloro, counting from the right to the left. So on carbon 3, you have Cl. And the rest of the carbon structure is where you're going to fill out the blank to make up to exactly 4 bonding, whether it's a single or double. So in this case, they are all single, and I'm going to fill out just a hydrogen. Now, once you're done with this, okay, we can now look into compound B. Okay, you can see that we do have a C double bond O, which is the functional group of a ketone. So for a ketone, we need to address the position for the carbonyl, which is a C double bond O, and you can count from the carbon on the left or on the right. But in this case, I'm going to choose the carbon where it will give you the lower number. So in that case, carbon on the left would definitely give you a lower number, 1, 2, 3, 4, 5, compared to counting carbon from the right hand side. Now, once you have carbon number 2, and since carbon number 2 with a carbonyl, so that will be the position number, and since there are 5 carbon, I'm going to start with pent. Now, pentane. As if you are writing for alkane, you have an E at the end. So this is where I'm going to remove and replace it with the suffix. And the suffix in this case is on, O-N-E. So, and the function group is on carbon number 2. So as usual, between number and letters, there must be a hyphen in between. That makes the word pentane to on. Now next one, compound C is an ester. Now we know that is an ester because of this functional group right here. Now, to know which part, whether it is this one on the left or right side, to know which one we should start naming, we need to look at where is the oxygen, the single bond oxygen. So you're going to start by looking at the single bond oxygen, then, okay, pick the hydrocarbon, okay, choose a hydrocarbon right at the end to the single bond and start naming from here. So since there's 1 carbon, so that means the underlying the hydrocarbon would be given name as methyl with a suffix as YL, as in alkyl, as a side chain. Then to give the second part, we are now looking at okay, this group right here. So I'm going to highlight this one right here, okay, which consists of the C double bond and single bond O. And this CO is also known as carboxylate, which is the name for the functional group. Now, the reason why I am highlighting on this is because I would like you to look at the letter O and ATE. That will form the suffix as OAT. Okay, and now I'm going to put this OAT into these 3 carbon right here, 1, 2, 3. So that gives you carbon 3 carbon. So I'm going to have carbon 3 prop. Okay. Now, again, as if you're writing for the word propane, like alkane, throw away the letter E and put in O-A-T-E. Okay, so it forms the word OAT. So we have methyl space propanoate, okay, as the name of the ester. Now for compound D, we have suffix as Al, which come from aldehyde. So for aldehyde, it's a default with carbon 1 that must have this function group. Then you look at but, which means 4 carbon, and that means we start from drawing carbon 2, 3, 4. 4 carbon with carbon number 1 with C double bond O. And on carbon number 2, we have 2 methyl So I'm going to put in the 2-methyl group. So we have 2CH3, okay, and the rest is just fill up the space for hydrogen. And you must remember each carbon must have exactly 4 bonding. So you have 2-methyl butanol, okay, A2D. Now, once you get 3 correct, you'll be getting achieved for this section. And for part 2, you need to distinguish between compound B and D. So you can see that compound B is a ketone and compound D is an aldehyde. And in your answer, you must include reagent, condition, observation, type, and structure formula. Okay, so to distinguish between an aldehyde and ketone, this is a standard test. Standard test where you will have to sort of put some effort to remember them. And it's kind of easy because only aldehyde will show all positive tests for this chosen chemical test. So the first one is Tollens reagent. And the second one is called Benedict solution. The last one is acidified, okay, represented by H plus, potassium permanganate. Okay, number 4 is acidified, potassium dichromate 6. Okay, so you can choose any of these to give positive tests to aldehyde. So you can just focus on one. So I'm going to focus on just reagent. On the first one, reagent as Tollens reagent. And the condition would be warm. Make sure it is written clearly warm and not heating, because heating sometimes can be ambiguous. It can be heated up to boiling, which in this case is unnecessary, so do not try to avoid the word heating. Heating may also include reflux, which in this case is just warm. Okay, and the observation, for the observation, so before writing the observation, I'm going to address that B is a ketone, okay, and D is an aldehyde. Okay, and therefore the observation for B would be negative, okay, or no change, okay, when Tollens reagent is added. And for D, definitely we'll get a positive test. A positive test in this case, we need to address that will form silver solid along the lining of the test tube. Okay, and okay, you have to include both as observation in plural form. So do not just focus on D that shows positive test and mention nothing about B, assuming that the marker know that B is a negative. So always bear in mind, you have to write both. Now, next you have to give the type of reaction. Now, you need to bear in mind that all of these four all of these chemical written here, they are all oxidizing agent. So I'm going to put down short form. This is an oxidizing agent. So that means the type of reaction would be oxidation. So for bullet number 3, you actually just need to write down oxidation reaction occur. And the structure formula. Now, the structure formula can be quite easy, okay, because we are just going to focus on D as aldehyde. So after getting aldehyde, we are getting carboxylic acid. So we just need to add another oxygen to D. So I'm going to focus on the C double bond O. So for the structure formula, I am going to draw it right here. So you have C4 carbon and double bond, okay, O and OH. So this is the oxygen being added. Okay, you can see that the difference is only by 1 oxygen, and the rest is copy and paste. So I am going to copy exactly what I have for carbon number 2 as methyl, and the rest is just hydrogen. Okay, voila. This would be, okay, your structure formula for product, in this case as carboxylic acid. Okay, now moving on to the next molecule, you have conversion of 1-bromobutane to butanoyl chloride. So starting material is 1-chlorobutane. So our focus is right here. This is a functional group. And okay, we're going to start from bromobutane. Okay, 1Br right here. Okay, and we are going to convert the Br to OH. Okay, and then OH to carboxylic acid, COH, and then eventually changing this OH group right here with the Cl. So you can see that there is 1, okay, 2, and 3 steps. Okay, so let's focus on the reagent, condition, and the structure formula for each step, starting from 1-bromobutane. Okay, so your answer can be pretty straightforward. So you can start by drawing 1-bromobutane. You can fill up the hydrogen. Okay, once you're done, then we are looking into changing it to butane 1O. So for this reaction to occur, you need to address reagent would be, you can choose any alkaline solution, can be potassium hydroxide or sodium hydroxide. So up to you, but you must indicate it's a solution. So this is compulsory. Okay, and the condition for this reaction to occur is reflux. So we need to heat it up, okay, and warm enough to convert or to substitute Br to OH group. So this would be the structure formula. Okay, then from the alcohol, we're going to oxidize the OH, okay, into, okay, oxidation again means addition of oxygen. So I'm going to add in oxygen right here, and the rest will remain the same. Okay, and obviously to add in oxygen, we need reagents such as oxidizing agent, and you can choose acidified potassium permanganate. Condition, now, okay, we need to mention that it's heated. If you don't have the word heat, means that the aldehyde will form alcohol. The alcohol will form aldehyde or ketone. So in this case, it's a primary alcohol. Okay, so we are getting carboxylic acid straight away when we put down the word heat. Then from here, step 3 with carboxylic acid, we are now looking into the final product right now as acyl. So you can see that this is a substitution reaction by changing the OH to Cl. So in this case, you may use PCl5 or SOCl2. Okay, you can choose just write one of them, and of course you can also choose PCl3. Okay, but SOCl2 is more favorable among the three, simply because there is no byproduct that exists as liquid as acyl. So we do not have to separate the rest of the component, as the only liquid is acyl. The condition for this is room temperature. Okay, we do not need heating. So here you go. Okay, if we look at overall, we are now looking at these 3 steps, reagent, condition, and it's pretty straightforward, and that's how you score excellent for question B. Okay, now the next part of 2020 question number 1, this is also excellent question. So sort of you are trying to solve a riddle that fit with all the description in this bullet point. So you started with S as a branched molecule. So I'm going to highlight some of the keywords with a molecular formula. Okay, and it has the following properties: rapidly decolorize bromine water. So among all homologous series that you study, okay, there's one functional group that decolorize brown bromine, and that will be the double bonded carbon. Now, next, exhibit as enantiomers with a chiral carbon center. So we have to be a bit careful here because we do not have enough information to draw the enantiomers yet. So I'm going to leave out bullet 2 first. Then look at bullet 3. We have acidified potassium dichromate solution, which form T and does not react with Benedict reagent, which is ketone. So T, okay, give us a clue, okay, that is a ketone as it does not react with Benedict. So a ketone, that means it derived from secondary alcohol. So since it's secondary alcohol, okay, we will have an OH group. Okay, and the last one, we have water, okay, that form acidified hydrolysis that form two products with V as a major product. Now, in this case, okay, let's look at just trying to find the right angle. So, well, 5 carbon must have a branch. So I am trying to sketch somewhere. Okay, so we can narrow down our search. So I'm going to start from here, 5 carbon. But remember, we can't draw that 5 carbon one go because there must be a branch. Okay, and I'm going to start with 4 carbon. And one of the very important clue is a secondary alcohol. So which means I am going to put an OH here with a C. That will give me a secondary alcohol for this OH group. Okay, so that means that gives me no choice that the C must be here on this carbon right here. And what else? And it exists as enantiomers. So enantiomers means there must be 4 different groups. Okay, 4 different groups. So we have H right here, 1, 2, 3 different groups, and another 4 on the left. And okay, there is a possibility of having double bond on the first carbon. Okay, let me draw another one. We do know that there must be a double bond. So the question is, can it be on carbon 1 or carbon 2? Now definitely it can't be carbon 3 right here because this will exit for bonding. So in other words, there are only 2 possible situations. Now, to guess whether it's the first or the second, I am going to fill up the rest of the structure so you can see the answer clearer. Now, by filling out the H, will give you a clearer vision on which one is not a cis trans. Okay, a cis trans must have only two identical group, and in this case, you can see that we can see 2 identical group here, and for this it can't be 2 because we can see that there are 3. So, and this compound shows that it does not. So, in other words, we can't choose the second one. So, unfortunately, this is not the answer. So, that means it narrowed down just this one as answer for S. Now, once we get this as the answer for S, okay, this one right here, I'm going to put it right here, okay, for S. Then, okay, we can going to move on to T. So T is a ketone. A ketone is formed through the oxidation. So what I will do is I will copy down, okay, this part right here. Okay, so duplicate. Okay, so I'm going to put it right here. So the only changes that I need to consider right now is changing this OH to a double bonded oxygen. So first to put in the oxygen, okay, well, I will have to erase this hydrogen right here, okay, and so same thing. I have a C here. I'm going to use different color to show that it becomes a ketone, like this, okay. So this is compound T. So a secondary alcohol becomes ketone through oxidation. And for U and V, now U and V is a product through hydrolysis or addition reaction to the double bonded carbon. So that means now our focal point, okay, is right here, okay, the C double bond O. Now, the hydrolysis or the addition of water, okay, we are adding H2O, just to make it clear. This H2O will be split to H and OH. So these will be the two groups that will be added to H, to the T, okay? And V is a major product. So in other words, we have to think, should we put the H to the carbon number 1 or carbon number 2? So that is where we have the Markov-Nikov rule. So in my class, Markov-Nikov rule can be easily remembered as a rich get richer. So meaning to say I'm going to give the H to the carbon that already has more H. So in this case, you can see between these two carbon on the left and right, you can see the one being highlighted with the red color has 2 hydrogen, and the one on the right, there's only 1 H. So the H well goes to the C highlighted with 2 hydrogen. So again, okay, I am going to duplicate, okay, this one right here from the H. Okay, duplicate one more time. Duplicate one more time. Okay, so in the exam, it's just like you copy and paste. You redraw the whole thing. So what we have now is to focus on the C double bond O, just to make it fine. So I am going to erase this line right here and this line. Oops. Okay, just the bottom line. The rest remain the same. Okay, we just leave the OH as it is. Next, we are going to put in the H. Now, since V is a major product, okay, so I'm going to put the H on the first, on the carbon on the left, and then OH right here. With U, which is a minor product, I'm going to give it to the C with less hydrogen, and the OH goes here. Okay, so I hope this video helps for question 1.